In this video, we're going to perform some operations with functions that are written in function notation. And it's important to keep in mind what the notation is indicating for the operation. Here in this first problem, I'm trying to determine what 4f plus 3g of negative 1 is. And it is often helpful for people to rewrite this function notation in a manner that allows you to see what exactly is going into the problem. Most common mistake that happens is somebody will come through here and they'll multiply by that negative 1 when in fact that is not what it wants us to do. The problem wants us to take f times f by 4 after you put negative 1 in it, and add to that 3 times g after you had put negative 1 into g. So I need to find those values for f of negative 1 and g of negative 1. So f of negative 1, I put negative 1 where the ends are. And now that I put negative 1 where the ends are, I evaluate this problem. So that's going to give me 2 minus 4, negative 2. So f of negative 1 is equal to negative 2. So I'll go ahead and change that out. So it would be 4 times negative 2 plus 3 times whatever g of negative 1 is. So I do the same process for g. So I'm going to put negative 1 into g and evaluate. Gives me negative 4. So g of negative 1 is negative 4. And so now we evaluate this line. 4 times negative 2 is negative 8, plus 3 times negative 4, negative 12, negative 20. All right, another example here of a linear combination of functions, but this time instead of inputting a value, we're inputting an expression in terms of t. So I'm going to rewrite, just like we did in the previous problem, this as 2 times g of t minus 1 minus h of t minus 1, because I want to see what I am putting in to both of these equations before I do the operation between them. So begin by finding g of t minus 1. So I replace the t in g with t minus 1, and I write the rest of the problem. And so we do that, and that gives us 3t minus 3 plus 3, which just leaves us with 3 times t. So I'm going to go ahead and put that in and say, okay, we have 2 times 3t, because we wanted to multiply it to g of t minus 1. Now we have to figure out what h of t minus 1 is. So h of t minus 1 means go to where t is, put t minus 1 in its place, and then simplify the problem. So I got to expand that square. So t squared minus 2t plus 1, and then plus 4. And so h of t minus 1 is t squared minus 2t plus 5. So that's going where h of t minus 1 is. Now, when I'm putting this expression for h of t minus 1 in, I need to put it in parentheses so that way I get my signs right. So t squared minus 2t plus 5. And now we simplify from here. All right, here in this example, we're looking at the composition of two different functions. So the composition of two different functions basically means that you have a function that lies within another function. And the way you approach this problem is you start with the very inside. So I want to find what g of 3 is first. So g of 3, I put in 3 where all the x's are, and I evaluate. It gives me negative 16. And so that negative 16 is inside of h. So I want to turn around and find h of negative 16. And evaluate. Now let's look at composition written a little differently. A second way to write the composition of functions is using the O symbol between, in this case, G and F. And I personally like to rewrite this. I like to rewrite this problem as using parenthesis notation as G of F of 2 times Z. So that way I can see what is inside of what and where things go. So I need to start with the very, very inside, which says figure out what f of 2z is. So f of 2 times z. I replace the x with 2z. So 2z minus 2. And so that is now what goes inside of g everywhere there was an x. So g of 2z minus 2 is going to equal 2z minus 2 squared minus, and I always substitute using parentheses, that expression. And now we just expand and combine like terms. All right, let's look at another example of operation with functions using function notation. And this time we're just strictly working with the function of x, and then we have our instructions below. We want to find f of x plus h, and we want to subtract f of x from it. So in our expression, we're going to wind up subtracting f of x from whatever x plus h is. So I have f of x right now. F of x is going to be 2x plus 1. Now, I still need to find what f of x plus h is. So f of x plus h, I'm going to replace the x with x plus h, and then would simplify. So 2x plus 2h plus 1 is what f of x plus h is. Now I just put all these pieces where they go. So it said take f of x plus h and subtract f of x from it. Well, I need to put f of x in parentheses and then simplify. So I look at this, the two x's are going to cancel, 1 minus 1 is going to cancel, and it's going to leave me with 2h. All right, another example here, same thing. I'm given a function of x being 2x squared minus 3x, and I want to figure out what f of x plus h minus f of x is. So I'm going to start, we'll figure out what f of x plus h is. So f of x plus h, replace all the x's in the problems with x plus h. And then we're going to expand and try to simplify best we can. So it'd be 2 times x squared plus 2xh plus h squared minus 3x. Really nothing to combine there. Just a bunch of unlike terms. And we want to take that, we want to subtract f of x from it. So 2x squared plus 4xh plus 2h squared minus 3x, and I want to subtract f of x from it. So f of x in parentheses minus 2x squared minus 3x. And hopefully some things cancel. And I'm looking here, the 2x squareds will cancel because I'm subtracting, and the 3x's will cancel. And that will leave me with 4xh plus 2h squared.